pretend to be a JavaScript. Where is Brian? Okay. And Phil and Tony will be taking notes. Thank you, guys. And blue sheets are going around already. Our agenda for today, Vittorio will kick us off with the JOT profile for 25 minutes. Then Aaron will talk about OAuth for browser-based apps for 25 minutes. Danielle will have two sessions to talk about Depop and push requests. And Annabelle, I don't see her yet. She'll have 10 minutes, and I will wrap it up with 10 minutes to talk about the nested JOT. So let's get going. Vittorio. Oh, come on.
All right.
Do this again. Okay, Friday. Vittorio, it's yours. And I'll click this. Try, see if it works for you. Is this PDF or is it okay? So probably I'll draw it from here. Yeah.
You'll do it yourself.
Yeah.
Every time.
Yeah.
Okay. Thank you.
Let me know when to try.
All right. Buongiorno, everybody, and welcome. Thank you for taking the time to come here and hear about the progress we made with JWT profile for OAuth2 access tokens. How many of you guys read the spec? Hey,
that's not bad.
That's not bad at all. Thank you. Can we go back to So for the benefit of the ones that did not read the spec, and for the ones of you who read it while having drinks or other stimulants, I'll give you a very quick recap of what's in there, and above all, why we are doing this, because that will inform the various things that we need to decide. And then I'll very quickly go through some of the main changes, thanks to everyone who gave feedback and induced those changes. And then I'll place on the table 3 open issues and at least for one call for consensus. All right, so let's do a recap. Thank you. Great, so why are we doing this? Once again, in current use, most authorization servers for rent use JWTs for access tokens already. I have made former presentations in which I have presented some research showing that more or less every vendor conveys the same information. They just use different syntax. And so there is no interoperability, although there is the opportunity for interoperability. And also, given that everyone did this in organic fashion, very often they went through, utilitarian routes, which led them to do things that we might define anti-patterns and similar. So there is clearly a guidance void. It's not just a problem of interoperability. And finally, something that I failed to highlight during other updates. One thing that you observe very often in the market is the fact that more and more products are asking clients to send ID tokens, where instead they should ask for access tokens. Reason being that in order to actually make their job, they need to have a stable format that they refer to. They need to have the information that they typically get in the ID token. So the outcome is that if you want to use Kubernetes, you've got to send them your ID token. There are a number of flows in Amazon that require you to do the same. So the hope is that if we create a profile that actually plays in the access token the things that those products need, then we will curb that practice. Thank you. So in a nutshell, what we did, we defined a layout where we lay down the various claims that represent most of the concepts and type of information that we have seen vendors are already placing in their existing in production access tokens. we laid down some rules about, for example, determining what should go in the audience, how you would map certain parameters in the resource into the actual content of a claim, of a token. Then we went down with details about how you validate this token, like classic enumeration of rules. And then we took finally this opportunity to advise implementers for pitfalls, privacy issues, security issues that you might encounter when you place that kind of information in the access token. And if you want to dig deeper into this, we have a couple of links in other events in which I covered this. And just to make this a bit more concrete, this is what the smallest JWT access token would look like. And I'm sure there is nothing surprising in there. It's like basically what you would find in a skeleton ID token, plus one indication about who is the client ID, plus the scopes. And then if you look at the spec, there are other things that can be done. Any questions so far? Did anyone have their coffee? Did you check all of your emails, or are you still checking your emails, Slack, Facebook for work, or whatever you're using? All right, let's look at the open issues. So very quickly, what we did. Wait, attenzione, Tony has a question. Yeah. Go ahead, please.
It's just Tony Nadlin. So the question is, are you, go back, can you go back one slide? One more. So you said you were talking about guidance on token validation. Is your guidance meant to be normative, and do you expect to have some conformance? Do you expect conformance to come out of that? So like certain libraries would meet, certain validation libraries would meet certain conformance criteria?
You mean official test to certify that the library follows that?
But something that could be used for library conformance.
Well, I guess that's a possible outcome. Like to me, this is giving.
But guidance is supposed to, it didn't look quite all the way normative when I was looking at it, but.
I think it's fairly. Now, maybe I'm missing the nuance of the semantics of normative versus, but to me, the spirit of this is to help library implementers to know exactly what to do when they receive this token and how to decide whether they should accept it or not. Exactly in the same fashion as we have done for the ID tokens. Like here you have exact steps that you are supposed to follow in order to say whether this is valid or not. Did I answer the question? All right. Well, he is not having an adverse reaction. So are you satisfied with the answer?
No, we were just looking at, more of a normative document to come out, not necessarily just a guidance.
So you want an extra level of...
I mean, we would probably be looking, in something like OpenID, we'd be looking to do some conformance testing and stuff.
Yeah. So I think that the granularity of the guidance in here is definitely amenable to be turned into conformance testing. So I think it's a possibility for sure. Great. All right, so summarizing the changes since the earlier episodes. At first, all the claims in there were mostly mapping, having their source mapped to OpenID, and instead we changed these to actually go all the way to the JWT specification, which makes more sense. Then in the place where we mentioned that we would have tokens that represent identity, I was only mentioning OpenID, and instead now I extended it to mention also introspection and basically explicitly opened up to any identity, potential source of identity claims. So pretty much, and then also mentioned clearly that authorization servers are free to place whatever attribute they want in there, as long as they don't have collisions and similar. Then I added more details in the privacy sections, in particular as a result of early feedback and also misunderstandings. Like, for example, people started saying things to the effect of, now that I know the format of the access token, then I can look inside the access token from the client, which clearly not a good idea. So I added language explicitly to prevent that. Although I'm told that it's super early, I added anyway already all the registration templates for YANA. And then for the off time, I have an open issue, so I'll hold on that. And then I had an initial note in which I was saying a number of existing access tokens in production carry information about whether the user authenticated directly with authorization server or through an identity provider and a federation step. But turns out that there was no interest from anyone to actually make anything normative in there, so I just took it out. And then I had a note in there about finding out whether the token is actually a user token or an application token, and I have an open issue on that. But for the time being, I just took out the note. Okay, so here there is the list of the things that garnered the most interest and the most discussion that didn't end up with a clear conclusion on the list. So I'm hoping we can use this time to come to a conclusion. So, and it basically is the thing about distinguishing between subject type, and then some discussion about the off-time behavior, and then whether to recommend authenticated encryption or anything that use symmetric keys for signing or securing the access tokens. So let's look at the first one. Thank you. So here the idea is existing access tokens in the market for various vendors have mechanisms that are used for the API to determine whether this token was issued for a resource owner or for an application. As in, does the subject represent a user or an app? And there is a variant which is was the token obtained through a confidential client or through a public client, but is let's simplify and just look at users versus applications. And there are different ways in which people achieved this. Like, for example, identity server doesn't include a sub claim when the token is issued through client credential grant. There was a discussion on the list, and the consensus was mostly toward we must include, if we have a sub, the sub has to represent the entity that was authenticated, and in the case of the app, is the app. So you've got to have sub in all cases. So we ended up saying that, yeah, we do need to have that. So we cannot use this mechanism that those guys were using for determining whether the token is an app or not. Then Carl from Okta proposed maybe we can have a claim grant type, which includes the grant that was used for obtaining this. And apparently ForgeRock already has this claim, but in the list there were a number of voices saying we shouldn't burden the resource server with knowledge about this because it's an implementation detail on the client and authorization server. So we basically excluded that approach. Then there was a long discussion about whether we should impose that in the case of an app token, you just have the sub equal to the client ID, but that also doesn't work well because a lot of current implementations use different internal mechanisms for generating client IDs and subjects in their own formats. Subject can also be different depending on the relying party. So and also you don't want to allow people to choose their own client ID because especially if the client ID ends up being in the sub for the security reasons that we heard during the meeting earlier in the week. And then finally, there was another proposal that we didn't really vote on, which was let's just have a new claim that states the nature of a subject, as in the sub represents a resource owner or the sub represents a application. So here, basically, I'm asking you guys, do you have any idea for solving this? For me, I would love to have the last one, let's say having a new claim that expresses this. But I'm also open to the outcome of this is complicated, this has bad implications, and so let's not do this at all, and let's leave every vendor to worry about this aspect in their own, and let's not have it in the intro profile.
Just enrichers. So two things. One, if you are letting your clients pick their own client ID, you're already opening yourself to be.
Yeah, we said we don't want to do that.
Yeah. So that's where most of the problem of this usually comes in, because if the AS is controlling the namespace of the clients, you can make sure that, the client ID looks like a client ID, whatever that's supposed to look like. Or if you're letting your users pick, GUIDs as their username, something else is probably wrong. The other thing is that, okay, so I guess it's three things. Because the other thing is that in a deployment that I did, we played around with having the grant type claim there, and it wasn't very helpful, as it turned out. So we ended up dropping that and just differentiating based on the, it's like the subject, and there's a client ID claim that comes back from introspection. So if the subject and client ID are the same, then that signals that this is a direct client token.
Justin, do you want to elaborate on why you concluded that it wasn't helpful?
Basically, we figured out that it was kind of a weird bit of signaling of like how this token showed up instead of like what this token was and what it meant. So it's basically, it's saying how somebody got this token and not necessarily what this token should be good for and who this token represents. And so it was, I don't know, it was just kind of a weird mental jump. I mean, it is a handy shortcut because you're probably doing that. The other thing, and this isn't something that we ran into in production, but the other thing that we thought was that clients can use, client assertions to get a token on their own that's not client credentials grant type. And so it's not necessarily the right signal. It's it's standing in for something else, which is that the subject is the client ID. And so that's the logic that we went, which I think is the third option there. Finally, Annabelle has a draft for subject identifiers. Is that why you're here? No. Okay. But we should do that, I think. And fantastic. Annabelle thinks that's a bad idea. And it's her draft, so she's probably the expert. But perhaps something like that allows a little bit more structured definition could be adopted into this, because that would allow us to have more than just a single claim.
Can you expand on what is this draft?
So this draft is in the Sec Events group, and it's for security event tokens. It basically says there is an object structure for different types of user subjects, so you can have more than just a single subject string in the JOT, but it's all sort of collected into one sub-object. So you can have an issuer and subject field within that. You can have an email identifier, a phone identifier, each of them with a type field as well.
So is this something that goes in the value of the subclaim?
No.
Okay, good.
It's its own claim.
Separate.
Yeah, and there are rules about how it has to relate to the subject claim. And it's not intended for use in this space, but from a distance, there seems, squint right and they look close.
All right, thank you.
And now I'll tell you why that's a bad idea. Annabelle Backman, Amazon. So that idea flashed through my head, and the idea of using subject identifier for this. The reason I think it's a bad idea is that what that draft talks about is subject identifiers and types of subject identifiers. It does not talk about types of subject. So it's saying, I am pointing to some principle that is the subject, and I'm pointing to it using, for example, an email address or a phone number, or theoretically a key pair, or any number of things that we might define down the road. It's entirely possible that we will have subject identifier types that are ambiguous as to, they could be handles to a user, they could be handles to an app, they could be handles to an organizational entity, any number of things. So I would not, it might be interesting to look at that draft as maybe there's a parallel approach to follow here, But I would not say throw subject identifiers at this specifically.
All right.
Now, what I actually got up here to say is two things. I agree with not using grant type in particular because it is tightly coupling this concept to specific protocol implementation details, and doesn't really make sense to tie those together. What makes sense as a mapping between those two, which grant types apply to which subject types, that mapping may change over time. It's going to get more complex as new grant types are introduced, as new subject types are introduced. It's unstable, and it would be really burdensome to try and ask the resource servers to all figure that out and understand that. If you're having your resource servers understand that, then at that point, there's probably enough coupling between your authorization server and your resource server that you don't need a standard way to do this anyway. I had a third point.
Which hopefully says how we do it.
Yes. No, actually, of course not. That would be easy. I was wondering if you could quickly summarize what the use cases are that people are solving or trying to solve by differentiating between user and app ATs, or what are the circumstances where they need some specific mechanism to do that?
So I tried to tease this out from the people that were already doing this, and this case was mixed with a case in which the API wants to know whether the client was confidential or not, mostly because that gives more guarantees about that client ID actually being the client. And the other case is for when they want one particular client ID to be I would say the one that actually, the one that is the only one that can call. And there are certain authorization servers that can use the same client ID in a different capacity. You can have a client ID that when you're using it from an iOS app, is just doing the public client flow with code. When you're using it on the server side, instead, you can do the proper client credentials.
Okay, that sounds like it's less about user versus app and more about what are these circumstances under which this client, and by client here, I mean remote piece of code that is calling me, what are the circumstances under which it's been authenticated, and what are the circumstances under which whatever user may be interacting with it was authenticated by me? I think that's very different from user and app. Like when I hear user versus app as two different subject types, what I think of is kind of three-legged OAuth versus two-legged OAuth. Like, is there a user involved in this relationship at all, or is this just a client calling on behalf of itself? So I really think you're probably asking the wrong question here.
Okay. So,
and here
just one comment. Time check. We have a few minutes only, so you wanna try to. I think you have one more point. So if
Right. Yeah, I have 2 other points, but it's a good point.
Thank you.
Thank you.
Justin, Richard, what Annabelle just said, and I have a concrete example for that if people want to talk about it later with medical records. So
great.
It exists.
Okay. So in the interest of time, for this point, we'll go back to the list, and I'll tweak these to be rather than subject type, determining whether the client was confidential versus actually the authentication that led to the token.
I think Annabelle made a very good point. We need to rethink the question here and maybe then reach out to the guys again. I think that was a very good insight.
Perfect. Great. Thank you. Okay. This one is another tough one. The idea is that when you use these access tokens in, for example, a first-party scenario in which the access token is the only artifact that you're sending to the API, there are a number of things that you normally get in the ID token, such as the time at which you authenticated and the type of authentication that you use and similar become important because you might have policies that you want to enact on top of these depending on what you receive. And so basically we need to take this information and place it in the access token as well. And a lot of providers are already doing this organically in the wild. Of course, the challenge that we have in here is that the moment of authentication is not corresponding to what to the lifetime of a token. So basically here we are placing claims whose value is determined elsewhere. Like, for example, the moment in which you signed in and you got your first batch of tokens, or if in the middle of a current session, you have to do a step-up authentication, and then the authentication time changes, and the method of authentication changes, then next time you use the corresponding refresh token, we need to reflect it into the token. And here, like the need from the practical and business perspective, it's very clear. Let's say people already do this. So, but at the same time, when we discussed this, some people on the list expressed unease. So I just want to give the opportunity to the people that had unease to bring their concerns, and if you have alternative solutions that, of course, still deliver on the requirement, then this is your opportunity.
Brian Campbell Ping. I was one of the doubters, and I continue my doubt, but I accept that it's going to be in here because, yeah, requirements and people are doing it anyway. But I do get really nervous about what you just said, a step-up authentication in a session after a token was issued should somehow be reflected in the auth time of the next token on refresh. That sort of thing is like drawing a lot of links between things that aren't really linked. And I'd like to see it at least clarified to this is the auth time or the AMR or whatever that was used at the time of authentication that the grant was approved. Or I don't know the right language, it's hard, but creating some sort of ephemeral and imaginary link between an ongoing session, however one might describe that, and issued access tokens off of some other artifact or refresh token, I think is super confusing and potentially dangerous.
I agree it's confusing. For dangerous, I think we should expand it. I think that we'll have to solve this problem somehow anyway, because like to make another example, say that you have this access token tied to a session with a certain token, the refresh token, and the refresh token is supporting rotation. And say that someone abuses the rotation and uses the wrong token at the right time. And now you have to revoke all the refresh tokens and allegedly also the access tokens that were issued as part of that. So you already have that link. It's just that in this case, you are using that link to reflect potential changes in the off time. But in the other case, instead, you use it for doing the revocation. But the thing is, this link between session refresh tokens and access tokens already exists in various other aspects.
Part of that is when you say allegedly, it doesn't exist. It's potentially some link that's done at implementation time. And even if it does exist, it's super weird to have a step-up authentication that happens in a completely different context and have access tokens reflecting that were issued off of a different authentication context, reflecting that sort of in some magical real time. So,
sorry guys. Yeah, I need to cut the line here, and if you can wrap up.
Okay, so we are skipping also the last point.
So you can talk about this, the last point, but I don't want to.
Okay,
more
great.
Comments.
So for
Annabelle, you're good to go. So go ahead.
I just want to give an alternative view of where that would be useful, and that's if you are doing an OAuth 2 authorization request in a context where an earlier, say, password-based authentication happened, but because of the nature of the OAuth 2 authorization request, you need to do step up at that time, then you're going to have a case where your password-based authentication might have happened yesterday, but your step up, your two-factor, whatever you're doing happens now. So having those as two different pieces of information could be valuable. Having said that, I think given the ambiguity of the term step up and two-factor and all of that, and the wide variety of implementations, I think it's going to be very hard to really formalize a nomenclature for all the different things we're going to want to talk about here. So this may be a place where just having an opportunity for the different vendors to plug in whatever they need might be more useful.
Great. For time reason, not elaborating, but I'll call this out specifically in the list. There is already language in the spec which is along those lines. So let's look at it.
Yeah, and you can present this if
Great.
you don't just present
Perfect. So, and here I'll just present basically I have at the very beginning the recommendation to use asymmetric crypto for signing tokens, because it's just easier for people to have a fixed sequence of steps for retrieving stuff from metadata and similar. Aaron suggested that we should actually require it, and I'm not against it, but at the same time, I know that privacy-conscious people were pushing to also include in their recommendation to use authenticated encryption. The thing is that authenticated encryption today, the only specs we have all use symmetric keys. And that makes me very uneasy, because now I'm leaving as exercise to the reader something which is super important, which is acquiring the stuff you use for checking tokens. And at the same time, so basically here, I wanted to hear from you guys, but apparently we ran out of time.
Yeah.
Unfortunately, we ran out of time. Okay.
Sorry. Thank you, Tor.
Thank you.
Thank you. Aaron? Why is it?
Mike Jones, JWE does authenticated encryption, but first by using public key derivation. So the symmetric key is a transient artifact. It's all done using public key cryptography.
What is this?
Okay, this is going to be a whirlwind. I'm Aaron Parecki. Is this going to work?
Yeah, it should work for you.
Great, look at that. Who here has read this draft out of curiosity? This is a fun game to play. Great, okay, a few of you. So the summary of this draft is that it is recommendations for people who are building browser-based apps or JavaScript-based apps or single-page apps, whatever you want to call them, that are doing OAuth 2 in a browser, which typically means that the browser ends up holding the access token, but we'll get into some of that. So that's the sort of overall scope. This is sort of supposed to be the parallel to the native apps best practices that we already have. This is a summary of what the document currently says. Some of these points are currently up for debate. So the recommendation for browser-based apps: use auth code flow plus Pixie. Must not return access tokens in the front channel, which rules out the implicit flow completely. Must use the OAuth 2 state parameter for CSRF protection. It absolutely requires exact redirect URI matching. That's actually changed from last time we met. And there is a recommendation that authorization servers should not return refresh tokens. And that one is one of the points we're going to talk about. But that is what we had currently discussed before we started having discussions on the list. So some changes since the last meeting. Exact redirect URI is new. It used to say same domain redirect URI matching, which, yeah. I did a whole restructuring of the document to split this into describing essentially 3 architectural patterns for this kind of app deployment. And one of those architecture patterns is when everything's on the same domain: the resource server, the client, and the authorization server. And then there was a bunch of clarifications and typo fixes that a bunch of you helped me find, so thanks for that. This is one of the architecture patterns, single page app with a backend. And in this case, this is one of the things that I think we need to discuss a little bit more about what we actually want to recommend here. The recommendation here is basically that if your single page app has a backend, then you should actually do OAuth in the backend component and not do OAuth in the JavaScript code at all. The question then becomes, do we say anything about whether or not the access token should actually live in the JavaScript app, or if that should be something that is not the access token, like an encrypted session cookie or some other thing. That's a point up for debate. This is one of the architectures. One of the other architectures is a single page app without a backend, which I think is probably actually a less common pattern, but it is still possible to do this, and plenty of people do have situations where this is necessary, and that is where your JavaScript app is served from a web host that doesn't have any dynamic backend itself, and it talks then directly to the resource server and the authorization servers. And in this case, the browser app does in fact hold the access token, and it has to actually have access to it, and you can't do any cookie level protections of it. So same domain applications. This is one of the ones that's gotten a lot of discussion on the list, which I think we need to come to an agreement on what exactly is the scope of this document recommending here. So same domain applications, what I mean by this is that when everything is on the same domain or subdomains, so if everything is off of example.com, like resource server.example, api.example.com, auth.example.com, and app.example.com, they can all share cookies on example.com. So you end up actually not needing OAuth at all, for one. And if you do still want to use OAuth, there are ways to protect it better than actually having the access token end up in accessible from JavaScript. So right now, the document says, maybe you should just avoid using OAuth and do something on your own. Maybe that's not the best recommendation we should be making for an OAuth spec, but it does. But actually using OAuth as written in this situation is actually worse, because there are more holes that that open up when you have this protection mechanism that is already otherwise there. So that's the first point. The redirect step, where everything's being passed around over redirects, is where a lot of the flaws come from in OAuth, a lot of the holes come from, and you don't actually need to do that if everything's on the same domain. But having that separation between AS and RS and all that is useful, because it lets you centralize your account management and MFA and all that. So there's a couple different approaches we could go here. I guess we could say that the scope of this document assumes that you're going to be using OAuth already, and we ignore the case that you might not use OAuth and only talk about how to do OAuth in this case. In which case, what exactly do we say about this case? Is there anything unique about this case? Or we try to say that there is a particular recommendation for same domain applications that maybe it doesn't use OAuth, maybe it uses OAuth in a new way. So I'm curious about thoughts on this bucket. This is one of the three architecture patterns which we discussed in the last meeting and on the lists, and now we're kind of seeing that some questions around it. I'm going to look forward really quick. Yeah, okay, let's talk about this one, and then I have a bunch of other open questions.
Justin Richer, yes, this discussion absolutely needs to be in scope, because people coming in outside of the OAuth working group are going to be saying, I have a browser-based app, I've heard of OAuth, what do I do? And if I get to an official document that says, hey, if your app looks like this, don't use OAuth, I might actually do the right thing and not use OAuth. So I think it would be a dangerous disservice to the internet if we remove this part of the document. Yeah. That said, we do have to be very clear about the boundaries around this, which I think we can continue to clean up the language. There was some discussion on the list in the last couple of weeks about framing this in terms of, if your backend still does OAuth, that's fine, but that's outside the scope of this document. The other part of this is that I know a lot of developers will look at their SPA with a backend and will see a backend-less SPA with an API that they're calling. Even if it's on the same domain and all of that other stuff, conceptually, in a lot of cases, the SPA developer and the API developer are separated from each other. So they're seeing them as decoupled services, and therefore looking at OAuth as the solution for doing that. So because this really addresses a deployment pattern and not necessarily an application type, we have to be careful with how we describe that, so that we are routing people to make the right decisions. I think that's absolutely possible and absolutely necessary that we keep this in this document.
Vittorio, of zero, I agree 400% that we need to be giving guidance to people. And if the guidance is for this particular deployment, don't use OAuth, use these other mechanisms, that's what we should say. The thing that I would be careful about is helping people to understand the implications of a choice. Because this is something that I'm trying to do on our side of the product, but the thing is, if people do that and they write their API with some middleware which expects a cookie as opposed to a token, and then they take this API and expose it to other clients, and now this API is expecting a cookie, then the other clients will not be able to use it. Or if in the future they make architectural changes and this deployment no longer works, people need to understand that they need to backtrack from this approach and then use the other one. And then if it's likely that their future looks that way, then perhaps they should use OAuth in this particular case, because otherwise they'll do the work twice. So long story short, I think we should tell people this is a simpler way of doing this. OAuth might not be the right tool, but we also need to help them understand what are the implications of their architectural choices moving forward.
Yep, thanks.
It doesn't necessarily mean backtracking. It might mean
On the mic.
It depends on the software you're using. Sometimes you have only one.
Microphone.
All right, sorry. I wanted to clarify. It doesn't necessarily mean backtracking from the architectural choices. It might mean augmenting them. It is totally possible that an API can accept a cookie or an access token to protect it. There's like
Microphone. I'm hoping here
depending on the
developer stack that you're using, it might be easy or it might be complicated to do.
okay, but it might be hard.
Repeat that though.
It depends.
Sorry, pizza, pasta. He said depending on the developer stack, it may or may not be, but might be difficult to do that, which is fair. But I actually came up here to be JabberScribe on behalf of Dr. Torsten Ladderstadt, yes.com. He says, I think same domain applications do not belong into this BCP. If you want to describe that pattern, write up another ID. We need to either describe it with all the consequences, including a threat analysis and security recommendations.
So, okay, so I'm hearing a couple different things here, and possibly, we should probably continue this on the list, but possibly one of the ways to reconcile this is not calling it same domain applications, and instead trying to find a pattern that describes this architecture other than the fact they're on the same domain. Because
Sounds convoluted.
that's not a distinction that OAuth normally makes. So maybe that's not the appropriate distinction to be making in the spec. But we need to find, I think to Justin's point, we need to find what are people going to be looking for in this document when they have the situation we're trying to describe? What's their keywords they're going to be looking for? And that way we can still cover this content, but maybe not with the same caveats or same distinctions, which I think would also address Torsten's point, I think.
Yeah, we probably have to discuss this a little bit further, but it sounded like very different advice from different set of people.
Yeah.
So we have to find out what the majority at least thinks which direction we should go. Because I thought that was actually quite good in the sense that you are recommending not to use OAuth, but you're not saying what else they should be using. So in some sense, we're not doing a threat analysis for the other solution that may not be an IETF topic at all. I don't know.
Yeah, that's also a good point. If we're going to say don't do this, we should probably have somewhere else to send people to tell them what to do. Okay, so it sounds like we're not going to be able to get through this one in any more progress here. So let's move on to the next. Because I do have a bunch of other. Do you have something else?
Yeah, just on behalf of myself, really quickly, I do agree with Justin that it's fine if it's not in scope, but I think there's a real opportunity for sort of complicity by omission. If there's nothing no mention of it in the document, people will come to it and assume that means it's the right thing to do. So I don't know if it needs to be an architectural pattern or even just description and out of scope doesn't mean this, some mention of the possibility that this is not the only way to do it, I think is necessary in the document. I don't know how, but agreeing with Justin there.
Okay.
Thank you.
Any other points on this topic from people who I haven't heard from yet? No. Okay. So there's a handful of other open questions. What's the time check? 10 minutes. 10 minutes left? Okay. These are, I think, small issues, but these are all ones that we were not, that either there were some points on the list that I went back and forth on, we didn't come to an agreement on yet. So let's just start at the top. State right now, this spec says use it for CSRF protection, even though it also says use PXE. Security best practice says you can use PXE for CSRF protection. So those things don't quite match. There are some issues with the fact that the client doesn't know that AS supports PXE, but in this spec, the AS has to support PXE, so the client should be able to know. Do we actually want to still say that state has to be used for CSRF protection, or should I take that out because theoretically it's covered by security BCP and using PXE? Any strong opinions? If not, we'll just skip it and deal with it later.
DanielFetYes.com. I think so. We have very carefully designed the language that we have in the security BCP, so probably a reference to that would be fine. Which means, so use state, you must also use PXE. If you actually use PXE, you might want to drop state under some circumstances.
Oh, that doesn't sound good at all, because right now it actually says you must use state for CSRF protection. And I'd be rolling that back into like, you can.
Essentially that topic is covered by the security BCP, and I don't think this is special to the SPAs.
Okay,
so
that's fair.
Just rely on the security BCP, I think, unless we identify something that's really special to the SPAs.
Yeah, if there's nothing unique to SPA situation, then it is probably better to not mention it.
Yeah.
From Jabber, Philip says, leave it out or ref, BCP covers it.
Okay. Going to come back to refresh tokens in a minute. Password grant. Right now, it basically says you should use auth code and PXE, but if you really need to, you can use the password grant. Can we just say you can't use the password grant? Because I don't think that's a good idea for anybody. I'm seeing a bunch of nods of yes, let's kill it.
I'm in John Bradley, Yubico. I'm in favor of removing the password grant because it's just a bad idea.
Great. That also means I can simplify. I can make it a must-use auth code and PXE, which clarifies everything in the scope as well.
There's a +1 from Torsten and a +100 from Philip.
Great. Okay, that's pretty.
I'm going to raise him a +1,000.
Okay. Great. Section 9.8 in the document. This is, I might just talk to Torsten about this. There is a list of security issues specifically with the implicit flow. A lot of these refer out to the security BCP for the details, and it's just a summary of them. There are a couple in there that I didn't see in the security BCP that are unique to the implicit flow. And I put them in here because people writing JavaScript apps are coming at this with the history of having used the implicit flow. And I wanted to specifically call out, like, here's all the reasons not to do that, which is why you should be doing this instead. I think it was Torsten who suggested just saying, hey, go read the security BCP for this. But I think it's important to keep a reference to these in this document because of the baggage because of the history.
Justin, Richard, +1, we need to keep in mind what people are going to be looking for and what people are going to be using this document for, and that's more important than our idealistic structure of documents and information.
Okay. My goal here is not to repeat, not to duplicate all the analysis and the content in the security BCP. But I do want to have a summary of when there is an overlap. I want to summarize it and then link out to it. I think that's safe.
And you still refer to that?
Yeah.
Right.
Normally refer to the security BCP when it mentions one of the points I'm trying to make, but I think people are going to be looking for it here instead. Okay. For the, I kind of mentioned this. For the single page app with a backend, do we need an indication that the access token may be sent to the browser? And I guess that would be an indication to the resource server or authorization server that this access token actually may end up in a browser, which is not a confidential client, which has a totally different threat model than a confidential client. This is an interesting one, and there's no mention of this right now in the document, and I don't actually know of anything else that's sort of doing this. The benefit to this is that the AS would be able to make better decisions about token lifetimes and when it reprompts for authentication, things like that. As it is right now, if you write an OAuth app and you just go and you get a client ID and client secret and then just don't use the secret, the AS is going to think that it's a confidential client. The AS may know that the grant happened without the secret, but there isn't really an indication that whether that access token is, held tight or ends up in a browser. Does somebody want to, okay.
No, keep going, sorry.
So I don't know what the solution would be here. We would need to talk about what mechanism to actually use for this, but it would need to be some sort of communication about the access token or about the grant that says the client is probably going to give this to a browser, which is a much less trusted environment. Does this sound like something people would like to have a mechanism for, and then we figure out what the mechanism is later? Some nods. Anybody really opposed to this? Does anybody think this is totally pointless?
That's right. All right. Just a question. Do we really need to send access token to the browser for this kind of use case?
That is a good question. It makes some deployments easier because you can avoid having a separate session with the server. We could also say, don't do that, and force you to send it to make a session. But then that does limit your architecture a little bit. It requires you to do something else. I wouldn't be opposed to making that a requirement for this architecture though, because it does clean it up.
Annabelle Backman, Amazon. I'll say I think there are use cases for access tokens and other kinds of credentials being sent down to the browser and used directly from there. Can I interrupt? That it is the particular case of there is a backend that's going to be proxying API calls. So this is this particular case. For the case where the access token is totally in a browser, that's different. In the case where the access token is actually being acquired by a backend, but is there's use case for acquiring it on the backend and then supplying it to the front end for use from there.
Okay.
What I actually got up here to say is that I'm not strongly opposed to a signal that this token is going to be sent to the browser, but I think we have to be realistic about the fact that we're handing access tokens to a client and oftentimes we don't know what the hell they're doing with them. So I'd be cautious about creating a false sense of confidence in the client's behavior by including something like this. It's ultimately kind of opt-in on the part of the client anyway, and if you are being really sophisticated, you can probably detect things like this without an overt signal.
Okay.
Jabber on behalf of Torsten, he says, I don't believe this is a good idea without sender constraining, which I think makes it really hard, but and then Brian here on my own behalf, I think I kind of agree with Annabelle that I feel like trying to build explicit signals here is a super slippery slope that gets hard. we're going to have this is one specific instance, but it's like you want some kind of signal here for a client to tell you just how promiscuous they're going to be with the access token. And it's like, it feels really
okay.
not good to me. But it's like, when I set my password with a provider, they don't ask me, are you going to share this with somebody else and make different decisions about rotation policy based on my bad decisions or my signaling intent about my bad decisions?
That's a fair point.
Recognizing that it's going to happen, giving some
age
guidance about
verification.
how to protect it might be a good idea, but yeah.
Vittorio of Zero. I think that the argument that we can't protect everyone in every situation doesn't mean that we shouldn't when we already have some knowledge of the topology. In this particular topology, we know what's going to happen because we are telling the implementer how we want them to behave. And at that point, given what we said earlier about the scenario in which the resource server wants to know whether they are being called by a confidential client or not, in this case, it seems that having something that helps the authorization server, at least to withhold whatever would be used for signaling this was a secure client, should be a must. Let's say that I wouldn't feel comfortable with recommending people to do this without also telling them here is a way of somewhat diffusing the potential power of this token. And then it's true that people can take your tokens and place it in a public folder, Google Drive, and you cannot prevent that. But in this particular case, I think that at the very least, even if we don't make a mechanism, even if we don't invent a parameter, we should put in the notes. If there is any way for you to tell the authorization server, particular authorization server implementation, that's your intent, then you should make it manifest.
Okay.
Annabelle Backman, Amazon. I think we should think about what the alternatives are here for from a topological standpoint. If I'm a client and I'm passing an access token down to the browser so the browser can make calls directly, the alternative topology there is presumably be the browser client making a call up to my endpoint, and I'm resolving some kind of session token or something in the cookie to look up an access token in a database on my side, in which case I'm already dependent on something in the browser. Like it may or may not be exposed to JavaScript. Once again, my access token going to the browser, what does that mean? Does that mean I'm giving it to JavaScript? Does that mean I'm putting in a cookie? That you'd have to distinguish that. But my point is that we already have to think about the downstream effects of the client's decision of how to authenticate their own and how to secure their own interactions with the browser client. That impacts us whether the access token is stored in the client or in the browser or on the server side.
I'm gonna cut line after Brian.
It's actually after Torsten again. Be a jabber. Why using a backend if in the end you send the AT to the browser? Sick.
No, that is a fair question. Some people do it, is the answer.
Reasons is the answer. Yeah.
Reasons is the answer. And ITP. Okay, I think I'm out of time. But there's this whole topic which we unfortunately aren't going to have a lot of discussion time for. But the topic is refresh tokens in single-page apps. There was a lot of good discussion on the list, reasons that it's a good idea and also reasons that it's a bad idea. And I'm not seeing a lot of ways to reconcile this guidance. Right now, the document says you should not include send refresh tokens to browsers. That feels like not enough of guidance for the situation. There are a lot of reasons it's a good idea, reasons it's a bad idea. So some ways to resolve this situation, we could say there should be no bearer refresh token. So it requires some sort of proof of possession, which is sort of undefined in this situation right now. We could require that refresh tokens have a limited lifetime, and that would either time-based or based on authentication session. We could leave that part up to people, but requiring that they have a limited lifetime would, I think, help some of the concerns people have with issuing refresh tokens to the browser. Requiring that they rotate is probably a good idea. It's also mentioned by the security BCP. I feel like that's worth, again, calling out here and saying, go look at the security BCP for the details. If they are rotated, should the new one get the new lifetime again or keep the same total lifetime of the initial refresh token? Because if they extend out the lifetime, then it's essentially an infinitely long refresh token, which was one of the concerns about browser apps. Or do we just take out any mention of refresh tokens from this document because there isn't an agreement and you are just going to go and figure out on your own anyway? So that's the list of potential solutions I came up with based on the discussions. I don't know what the right answer is. I feel like not mentioning it is bad. I'm kind of leaning towards definitely requiring rotation and not having it extend the lifetime and making sure that's clear, because that helps eliminate some of the attacks people were describing. I don't want to not require bearer tokens, bearer refresh tokens, because there isn't really a solution for that right now, so it doesn't feel practical. Go ahead.
Okay. Brian, last comment. Yeah, go ahead. Cut the mic.
On behalf of Philip, SPAs need a way to get fresh access tokens or access tokens for another RS with using resource indicators without refresh token. What's a reliable way to get those? iframes rely on third-party cookie access, which is in the crosshairs of pretty much every browser vendor nowadays. Constantly redirecting blows UX. So does pop-up, since it requires in-user interaction, either we put forth restrictions on the AS and client to be able to get refresh tokens, e.g. using pop, center constraint, rotating on every use, something else, or searching for a completely new mechanism. Oh, Jesus. No need, sorry, apologies. No need to proxy, Brian. Aaron is on the same. So I guess I didn't need to do that.
Okay. I'm glad you got to the Okay. Well, that's a fun discussion. I guess what I'll do with that one is I will actually put together a little proposal and make a new thread on the list so we can talk about that again there and keep it going. So thank you very much.
Hello, Daniel Fett from yes.com. I'd like to present two things today. The first thing is the OAuth 2.0 demonstration of proof of procession at the application layer, or DPOP short. What do we want to solve with this solution? As you might know, the OAuth security BCP, and we've just also seen the SPA BCP, makes good points of using sender constraint tokens. But currently, we do not have suitable mechanisms for sender constraint tokens for SPAs, and probably also some other deployment scenarios. We have MTLS, which is good, but you cannot really use that in browser. And we also have token binding with a lack of browser support, and the future is pretty unclear of that. Therefore, in Stuttgart at the last OAuth security workshop, we started drafting a solution on the application layer. And I think Brian came up also with a name for that. That's on the bottom right corner. He saw it in the S-Bahn. That's how DPOP came to be. What do we want to do? The main goal of DPOP is to prevent token replay at a different endpoint. More precisely, if an adversary is able to get hold of an access token or refresh token, because the adversary set up a counterfeit authorization server or resource server, then the adversary should not be able to replay that token at a different endpoint, authorization or resource server. So that's the main goal of DPOP. As I already said, we started discussions in March. I created the first draft in Prague during the last IETF meeting. And now we are at version 0.2. And this is what the current proposal looks like. We have the client on the left, and when the client sends the token request to the AS, then the client attaches a DPoP proof. What that looks like, we'll see in a moment. And then the client gets back, if the AS supports DPoP, an access token that is DPoP bound. This is signaled by the token type DPoP, and also refresh tokens for public clients at least that are also bound to that DPoP key. And then when the client wants to use an access token, for example, then it also has attached a DPoP proof to that one. And it's noteworthy that we use the same proof structure, the token structure, so to say, in the token request and in the when the access token or refresh tokens are used. Is this? Okay. This is what a DPoP proof looks like. In a header, you can see that we have a type of DPoP plus JWT, and we have a public key. And in the body of the JWT, we have things such as a token ID. We have the HTTP method of the HTTP request to which the token is attached. We have the HTTP URI, and we have a timestamp. And all of this is, of course, signed with the private key that belongs to the public key in the header. In a token request, the DPoP token is added to a new HTTP header called DPoP. And when, as I already said, so this is additional to all the stuff that we already have in the token request, which is completely unchanged. If the AS supports DPoP, then the AS will send back the access token with token type DPoP. Otherwise, if it doesn't support DPoP, then everything will go as normal, and the client will see that the AS does not support DPoP. Now, the resource access, in the resource access, there is an authorization header as before, but the token type is not BIRA, but it's DPoP. Therefore, the header is DPoP and then the access token. And there's a DPoP header as before with the DPoP proof belonging to the resource access. In the introspection response, or if you have a JWT access token, there's a CNF claim signaling that the access token is bound to some key. And in the CNF claim, there's a JKTS256 claim, which is the base64 URL encoding of the JW key SHA-256 thumbprint of the public key to which the token is bound. That is, the resource server can check that a DPoP proof was presented for that access token. Regarding the security of DPoP, we have several features that prevent token replay. We have the JTI, the token ID, and IIT, the timestamp, which together can be used to maintain a list of tokens that have been seen and that would, in theory, be still valid. We also have HTTP URI and HTTP method, which bind this token to the access or to the request that is made. To prevent a swapping of DPoP tokens, DPoP proofs with other JWTs that are created somewhere, we also have a type claim, which has the unique value that must be checked. We don't allow the signature algorithm none. And regarding message integrity, which is not guaranteed by DPoP, as you can see, there's no signature about the message body. Of course, you have the transport layer. Of course, use end-to-end TLS if possible. But really, if you want to prevent that a token resource endpoint that is manipulated or that is malicious uses the token at the same URI at the honest endpoint, then you can, with changing the request body, then you can also bring your own data and sign it in the DPoP token. So it's extendable if you really want to do that, but it's definitely out of the scope of this specification. MTLS is a more robust mechanism. If possible, use MTLS, but as I already said, in some situations, it's it's just not possible. Okay, Hannes.
Yeah, speaking as myself here, we have existing working group items that pretty much do the same stuff. They don't have this shiny name though. And I was wondering on whether you had sort of like considered that work, because one part of the work is actually split in two documents. One part is the key transport, which we talked about last time, where Thorsten made his comment about do we need to add a proof there, and which was followed up with this formal analysis. And then we have the second piece of work, which Justin was or is spearheading the signing, which of course has the very same, does more or less the same stuff we had different incarnations because there were issues, challenges. I think that's fair to say. Request signing had always had some challenges in this group. So I'm curious on what motivated you to come up with a completely new mechanism instead of just reusing what we already had and help to sort of get that finalized.
So I think others here might chime in on that because they're more familiar with the other drafts. I can say that Depop is a very simple, very concise mechanism. That is, we also have already some working implementations of that.
The other thing is too, because it actually does less, like from a functionality point of view. And what we previously did with the ACE working group, we tried to, as you remember, we tried to balance this work with ACE and RTC Web because they needed a proof possession mechanism, and they also encoded the fields in CoAP, and we had the corresponding parts in HTTP because we said that we would do the HTTP stuff here. The ACE working group does the CoAP stuff there. So that was kind of a understanding, and so now I'm feeling we're doing the same thing twice. Even like you had in the earlier slides, you had this, you call it a Depop proof of possession. I forgot what the name was in the other case because it was also binding the key to the token. So
yeah. Well, maybe. Yeah. Go ahead.
Okay, so not Sakimura, all right. So I was, kind of wondering the relationship of this draft to the key distribution draft, which is a working group item. And signing draft, as well. And then also there's a draft that I wrote a while ago, which is called JPOP, which a part of the spec was actually taken out to become MTLS. But this one looks like trying to do more or less the same thing, except that this can only be used for code flow. While in that case, because we are relying, JPOP is relying on key distribution, it can actually be used for implicit flow as well. Yeah.
Brian, try to put some color on the origins and some history here to at least not address, but talk to Hannes' questions. Depop came out of, I think, a desire and a real need from developers using this stuff for a simplified, concise mechanism to do public key proof of possession for an access token, both at the authorization server and the resource server. And while it bears a lot of similarity to some other things that are in progress, it does, how do I say this? I think it does more with less. It delivers that public key proof, and for both the delivery and binding of the access tokens with the authorization server, as well as using them at the resource server. So it's it has a lot of conceptual similarities, but I think it's significantly simpler, has a more straightforward model, and is much more concise.
I ask you on explaining me where it is simpler, like for the two interfaces, for the interface from the client to our authorization server, where's the more simplicity than the key distribution?
It's both in the. Well, in my view, it's simpler in the key distribution because there's not the overhead of the potential of symmetric keys. The key distribution itself works the same way for both presentation to the RS and the AS. It's the authors, it's the client saying, here's my key, here's proof of it, this is what I want to use.
And it's, I imagine it's super simple from implementation
The reason why
standpoint.
there's symmetric keys because we worked with these other groups that asked for symmetric keys and they have asymmetric keys today. That's why it's in there, because we had to align with these other groups.
So I think you're getting at sort of a natural tension here that you're working with those other groups and they've taken on a lot of.
Not just me. It's like we have.
There's work here that's aimed at deployment and use in the wild. And I know there's other groups that's building on top of OAuth, but this is specifically geared at deployment and usage. And the proof of possession key distribution stuff has taken on a role of being an underpinning for additional work within ACE. And I guess other work that I'm not aware of on RTC Web. So there's some tension there, but this was maybe an end around from that work because it has a more explicit and straightforward goal, including not symmetric keys, because there's no mechanism for proof of symmetric keys, and trying to account for that significantly complicates things, as you're probably aware, trying to have written it in the document.
Jim, you want to talk about if you're aligned with ACE? I don't know why not.
I mean, I frankly, I've wondered at times whether the POP key distribution document shouldn't be in ACE, given that that's the.
Actually, we had that discussion, and this group decided that it has to be here because it's the HTTP part.
And that's not what ACE has to do with contracts. Yeah.
I don't recall that discussion. I'll step aside.
So on the topic of symmetric, I was going to actually ask the question of why the spec specifically limits this to use of asymmetric signature algorithms. We found that there are use cases where asymmetric signatures are still just too slow.
The idea was to make this as simple as possible.
Okay, so I guess the question then for the working group is there a significant enough win in terms of simplification to warrant having a mechanism for proof of possession that is specific to asymmetric signatures, or does the proliferation of POP methods kind of outweigh that simplicity gain?
Yep.
The other comment I have on this is the draft mentions being able to bring your own data piece, but it doesn't really get into exactly how that would fit into it. The job, it doesn't provide any I would expect to see at least some claims defined for the typical things somebody is going to want to sign, like a request body or headers or yeah.
Yeah, so maybe we can draw from.
I'll get to some of why that is important in my talk.
Okay, good.
So the origin of this came from the security.
I'm going to cut the line, sorry. I'm going to cut the line right now.
John Bradley, Yubico. So the origin of this came from the security workshop where we were specifically focusing on what could we do for single page applications to do proof of possession should token binding not come to fruition. So we said, okay, we could use web crypto and create a non-exportable key in the browser, and these would be the mechanisms that we could do it. So that's why is there no symmetric keys? Because there is no way of protecting a symmetric key in the browser and being able to do proof of possession. So this describes how we can address that particular use case. This lays out a way to do it. If the working group wants us to refactor, yes, we did take the ideas of Justin's draft, which is not currently active, but I believe it's expired. Okay, so it's expired for reasons. So it is entirely possible to profile, should we reconstitute that document, we could profile that document. This is what we specified as a subset of that document. And arguably, the way that we're publishing the key to the authorization server at the endpoint is a subset of key distribution. But we're not distributing a key. We're using a very small set of that. So could we do this as profiles of those documents? Should those documents actually be active? Sure. But this is essentially our core use case document. If you want us to refactor it to use other specs, okay. But those other specs have to actually exist and be making progress. But this is a concrete use case of something that people actually want to do to bind tokens, as we talked about in Aaron's presentation. There is no way currently for you to actually do proof of possession of the refresh token in the browser. Should somebody use this mechanism, they can actually protect the refresh token in the browser. So this is a real use case. I think we need to actually address the use case if we want to address it in the very narrow sense. And yes, we took out all of the other stuff that addresses a bunch of other use cases so that we could actually focus on what's the minimum that we need to do this. If we want to refactor this to point to the other specs, I'm perfectly okay with doing that. We're not saying that the other specs don't have value, but we needed to focus in on what is this use case, how can we solve it? Exactly how we format the spec, I'm completely open to it.
+1.
Mike Jones, Microsoft. I'm actually representing right now our engineering teams who did a detailed analysis of whether and how they would use the spec. And there were 3 sets of comments they had. One was they want to use different POP keys for access tokens and refresh tokens. It's my belief, doing a cursory analysis, that they could just use different keys in the request and have that work. And the keys are not just maintained as state between different requests. Off the top of your head, am I right?
Yep, I think so.
Okay.
Could be.
Okay, think about that, but I think I was right when I told them that. Second, they were a little bit surprised by the tokens issued being bearer tokens, and then there secondly being a proof that's distinct from the token, which it's up to the recipient to check the proof using information in the bearer token that it actually is attested to. Now, I understand the reasons for that, that you could, by adding this proof header, continue sending the access tokens using 6750, using authorization bearer token, and resources that don't understand that there's also a proof.
That's not how it's currently in the draft. So currently we're using the so we're using the
okay, educate me.
The depop. This is how we do resource access currently. And as you can see, it's not a bearer token because it's not. So it says depop, and then you provide the header.
Okay, they would actually be happy with that because they don't want to just add information to an existing thing, because some resources would break even though they're not supposed to. Thank you. I will report that back to them. And the third thing, which I filed an issue on several months ago, is despite some of the sentiments in the working group, for years we're going to continue using the implicit flow, and that's not up for negotiation. So they want a description of how to use Depop with the implicit flow if they're going to use it at all. So that could either happen in this draft, or I could create a separate draft. But if we're going to use Depop at Microsoft, there must be an implicit binding.
So I think this is something we should talk about after, if the working group decides to adopt this item, to discuss what the working group thinks about this.
That's fine, but I'd also like to talk to you and some of the authors about what technically you think that binding should look like, and I want to get it written down. And it's a working group decision whether to adopt that piece of it or not. But I have a mandate from my employer to create it either in this draft or as a separate draft, if we're ever going to use any of this.
Yep.
And I just wanted to put that on the record. Okay. Brian off mic said he would be happy to see it in a separate draft and would work on it with me. Thank you.
Justin Richard, to that last point, I would be unhappy to see it in the same draft. So +1 to Brian's point. All right, since my name was tossed around a bunch, I figured I should get in the mic line. Having tried to spec out HTTP signing and implemented a number of different signature methods, I think one of which we're going to hear about later, it's really hard. It is really, really surprisingly hard. I'm with Annabelle that there should be a few additional fields, but I mean, that's it. You have a structure, we can add that, we can specify that, that's great. Signing headers and signing body, very important in other types of requests.
Yep.
Yeah, totally. I really like this approach. I agree with Hannes in principle that having a server provided key to enable symmetrical keys and stuff like that helps a lot of different use cases, embedded use cases especially because of key generation costs, but other use cases potentially as well. And even having the server generate an asymmetrical key pair makes sense. I know.
But
it makes,
we don't have that functionality.
Depop does not have that functionality. I know, Hannes. Can I finish my sentence?
None of the documents has the capability to server-side generate asymmetric key pair.
I thought that POP distribution allowed that. Okay, well, that's a gap in POP distribution, and that's dumb. So anyway, ultimately, if this is cryptographically agile enough, I think those are details that will fall out. The mode of the client presenting and proving possession of, that's an important part, proving possession of the key that it is saying I'm going to use is a really, really important pattern, and that actually solves the security use cases for the majority of ways that we want this thing to get used. Because if the server provides a key, the client hasn't proved yet that it can actually use that key to do anything. So I like this pattern so much that I also invented it because this is how currently key proofing and possession works inside of XYZ. So it's the same kinds of structures. And yes, before Hannes asked, I was aware of my other draft for HTTP signing. So, and I purposefully didn't use it for this because that is a really complicated thing, and there really has not been enough energy in the working group to move that forward, possibly because we have cabbage signatures, we have a bunch of other things that have been making progress that people could use instead. Ultimately, I don't care where that draft lives. If we were to take all of the proofing stuff in here and paste it into the HTTP signatures draft and call that the new version, fine, you know, like whatever. And I think that we might be able to do that if we extend a couple of fields with some normalization rules, you know, that's all doable. So yeah, at the end of the day, message signing and for key possession is something that we need, something that we have needed for many years, but we haven't solved yet because it is really, really, really hard, and we keep getting stuck on little bits and details instead of just trying to do something.
Howdy, Roman Danilio is the responsible AD. Taking no technical position on what we just kind of talked about here, that's for the working group to talk about. What I would strongly urge before we talk about working group adoption, we make sure that we better understand the equities of perhaps other working groups, put them on the table. I actually don't know what all those equities are. We should check and make sure we surface them as we reason about what to do here. And ditto, I heard that, again, this is kind of my first real meeting with this working group. As we talk about past decisions, the fact that we don't remember what we decided, and that's kind of coming up, there's ambiguity in that. Let's just kind of surface that as we figure out what, the scope of and the boxes of some of these drafts. And so let's again surface what the equities might be in the other working groups to inform us. Thanks.
Okay, thank you.
Yeah, that's good summary. So we're not going to be able to adopt this document at this time, so we'll take it offline. Okay? Just go ahead.
Okay, can you make it full screen?
Yes.
Okay, my next presentation is about, this is cut off on the bottom, I think. Where is it?
Try to move forward.
No, it's not. You have to go to the single. Yeah.
Try again.
Yeah, that works. Okay, my next presentation is about push request objects. And the aim here is to find out whether there's interest in this working group to go forward with developing something in the IETF. What are push request objects? You might know that there's the JAR draft that moves request object management to the AS. So this is an extension that would move the request object management to the AS. As I already said, this was developed in the OpenID FAPI area based on experience gathered in open banking /BSD2 context. What is the rationale here? As you might know, in JAR, we have a mechanism that ensures the integrity, authenticity, confidentiality of the authorization request by essentially signing all that stuff or whatever. And the problem is, if you put the signed JORD, for example, in an authorization request by value, you would put it in a request parameter, you end up with very lengthy URLs. There might be a lot of scopes in them, for example, and the JORD itself is very long. So there's a method to transport it by reference called the request URI, where you put the JORD somewhere on some URI, and then in the authorization request, you have the parameter called request URI that refers to that URI. So the AS goes to that URI and takes the JORD from there. Problem with that is the client, if it puts it on its own server, needs to handle inbound requests from the AS, which is a new thing. The client needs to store a potentially large number of objects and also handle cleanup for them. There's might be delays in the authorization if you have problems with latency or if the request URI is not available. And the AS also has to make outbound HTTP requests. That is, you enter the whole domain of server-side request forgery problems, which are a lot. Ned, there's an input from you.
So just a point of clarification. The JAR draft actually doesn't require clients to store the request object.
No, it does not. The JAR draft says put it somewhere. It can be on the client, can be on the AS, can be somewhere else, and at least open how to do that. Yeah, that's right. So this is kind of left open in the draft. So the push request object is essentially a description on how to do that. The idea is to move the stuff to the AS, so the responsibility for managing these request objects, by creating a new request object endpoint. So the client calls this endpoint, delivers the request objects, say with a post request. The client is then provided a unique URI to that request, or the contents thereof, and this is then used as the request URI parameter. Essentially, the jar draft already foresees exactly that. I think there's a sentence somehow outlining this idea, but this makes it more concrete. There could be two modes. The request object could be stored as a JOT if you need the features like signing, encryption, whatever. Or it could be a raw request object just in JSON format to keep it more simple. This would look like this. This is the post request to create the the request object. So you would send a post request, and in a post request you would have a JSON with all the parameters that you otherwise would find in the authorization request. You could also have this as a JOT, then you just post the JOT somewhere. In the response, you get a request URI containing enough entropy so that it's unguessable by somebody else. And then when you send the authorization request, all you need to send is the one single parameter request URI containing whatever you received before in the request URI. That is the mechanism. As I already said, it has some advantages. There's no request object management on the client itself. Deployments can choose from these two options to have a JSON or a JOT. We can have client authentication at the endpoint where the request object is posted, so you can refuse unauthorized clients very early in the process. And also you can have patterns where the authorization process itself relies on the identity of the client, because you now have essentially proven the identity of the client. And also because we now have the option to transport very large authorization requests, this is also a good foundation to convey something like rich authorization requests, aka structured scopes, where you put a lot of information in them. So you're not limited, for example, by the size of the URI, while still having a defined implementation pattern. So the question is, what are your opinions? Shall we bring this to the IETF or rather not? Go ahead.
Hi, Aaron Parecki. I think all these are very good points. This makes a lot of sense. I just wanted to point out that this is almost exactly what I implemented when Justin first started talking about XYZ last year. The initial thoughts behind that, I did almost exactly this, just as a plain object, not wrapped in a JOT. And it was super easy to add to an existing OAuth server that I had. And it made a lot of sense. So I just want to throw that out there.
Thank you.
John Bradley, Yubico, one of the JAR authors. So JAR has been in flight for a while, perhaps too long. As it closes in on completion again shortly, things have developed over time, and this pattern has become clearer and clearer as being preferable. We left it open, JAR open to this pattern, but didn't include a whole bunch of new text. Had the timing been different, this might have gone into JAR, but we don't necessarily want to reopen and extend, since some people are counting on JAR finishing, so that for some of the payment stuff, we don't necessarily want to delay that. So doing this as a separate draft makes sense. We'll probably debate whether or not the raw format or an unsigned JOT is preferable. So there are a few details in it that probably merit discussion, but yeah, as an elaboration of JAR, this is probably should happen so that we have a consistent way of doing it. And as I say, we would have done it in JAR had timing potentially been different.
Yep.
Annabelle Backman, Amazon. So I want to point out that this is very similar to what the device authorization draft defines in terms of we're pushing a request up to an endpoint on the AS, we're getting a URL back, and then we're opening that up. Or we're in this case, you're adding that to an authorization request, but
Yep.
ultimately you're getting a URL and you're opening it up. The only real difference is the other direction, how the response then gets back to the client. So
Yep.
it seems a little bit weird to me for us to standardize 2 different methods to do, and potentially 3 different methods to do address the same challenge of how do I securely make this request to the AS? I know device authorization is very far along in the process, and I don't necessarily want to say we should derail that, but maybe we should look at the fact that we're treating both sides of this transaction, the get to the AS and get back, as if they're intrinsically linked, as if the mechanisms by which that happens are intrinsically linked.
Yep.
And maybe we should decouple those and look at standardizing those separately.
Gonna cut the mic after Nat.
Thank you for that introduction, Annabelle. Justin Richards. So, obviously this, once again, this pattern shares a lot with XYZ because I stole all the best ideas from everybody and put them in one thing. And a lot of the motivation was noticing that there was a lot of overlap between things like the device flow and request object registration. But I actually tried to do the exercise of collapsing those two within OAuth2, and you really can't do it. There are bits and assumptions made on both sides that if we were to try to like twist this into device flow or make device flow look that it would break the models for both of them, right? So unfortunately, I think that if we do want to bring this in as an OAuth2 extension, it does need to be its own thing, and that is a shame. But to me, that is also motivation for next generation protocol that doesn't have those same assumptions, that can actually split, how you get the user there and how you get the user back, which is exactly the structure that XYZ has. I mean, this is the world that that project came out of, right? And that said, I've implemented this. I do think it makes a lot of sense. It does solve some key use cases. It's being very, very similar things are being used today in the financial space. Some of them proprietary, some of them sort of pseudo-proprietary cabals. And so having a standardized way to do this, I think, is a really good idea. There is an open issue about the request format, which I have some strong opinions on, and maybe some sad acquiescence about where it's probably going to go after talking with Brian. But if we bring this into the IETF, that will all obviously need to be aligned. I think we should bring it in. I think it fits under the group's umbrella. And just to reiterate, I think this is more motivation for working on a new protocol that also does this stuff, but in a cleaner and better kind of way without all of the legacy baggage that this of necessity has to deal with.
Yeah.
So just a couple of clarification again. This is related to the scope of this document. Sending the request URI to the authorization server and authorization endpoint actually is covered by jar. So it's out of scope of this document.
Yep.
The scope of this document, I think, should be just pushing the request object to the authorization server and just getting back the response, which includes the request URI and period. So small and concise document. Yeah. I just wanted to make sure that people understand.
Yeah.
Okay, good. So how many people read the draft? Show of hands, please. 1, 2, 3.
It's not much to read.
It's not
Okay.
actually
Okay.
IETF
Okay. Okay, but
Yes.
I thought it is. Okay.
So
Okay.
the
So it's not an IETF
the question is,
I
do we
see.
want to, so it's their interest in
Okay.
the group to go into that direction. So
Okay.
it's not about
Process.
specific term.
So for all the whispering for kind of everyone else, I mean, the specific thing is we're talking about, I want to clarify, Roman, we're speaking about, is this the idea we want to bring in? We're not talking about a specific
Yeah.
kind of document
Right.
because the document is
Exactly.
not in the kind of
Okay.
IETF.
Exactly.
That's true.
Okay, so I'm gonna then call for a hum here and see, get a feeling of the room if there is support for that, okay? Go ahead, sorry.
Roman, I just want to clarify, the hum is that we think we want to bring the idea into discussion.
Correct.
Exactly.
Correct, yes. Go ahead.
As an organization thing, I was confused whether the document is an ID or not.
No,
or
it's
whether.
not.
No, it's
Thank you.
not.
In some sense, we can't really hum whether someone is going to write up an individual document to bring it to the group. I think what we've seen on the microphone is a couple of people saying, "Oh, that sounds like a good idea."
So Roman speaking again to clarify, the hum we're about to do is that someone that participates in the IETF community has an idea and would like feedback from the community in a very concrete way that he and his team should work a lot harder and bring something to the IETF, which then we'll decide further again if there's a
Yeah.
draft, whether
Exactly.
we want to do working group
Exactly.
adoption, check charter scope and the rest of it.
Exactly.
Yeah. So that long phrase is the hum.
Okay, if you are, I guess you've heard the request here, so so I'm gonna ask you to hum to support this or not. So if you support this, bringing this work to the IETF, please hum now. If you're against bringing this work to the IETF, please hum now. Perfect. Thank you.
So to
Thank you.
confirm, I heard almost everyone humming in the direction of to bring this to the IETF, which is a non-binding in every way. But that is your feedback.
Thank you.
Thank you. Annabelle?
There was one more before me. So this is going to be interesting. So I just looked and like half my slides are missing. So that's cool. So I'll kind of wing part of this. That's okay. So what I want to talk to you all about is how we do HTTP request signing in AWS using a format that we call signature version 4. Guess why? So in brief, quickly, why and what is this all about? There's three specific things we're looking for. There's three specific things that we get out of request signing in AWS. First is authentication of the client that's making the request. Second, we do it for message integrity, which means we're actually signing a significant number of the different parts of the request, as you'll see. And then we have some element of replay prevention that we get out of this as well. Virtually all requests to AWS APIs are signed using signature version 4. There's a few exceptions like anonymous requests to S3, but for the most part, if you're using AWS, you're signing things using this algorithm. As far as what goes into these signatures, like I said, we're doing it for message integrity, which means we're hitting a lot of different parts of the request. Method, endpoint, path, timestamp, query string parameters, body, and some of the headers. And I'll show you how some of that works in a moment. And then we're using HMAC SHA-256 with a key that is derived from a shared secret to do that, which is why I was asking about symmetric versus asymmetric earlier. So there's three, so I'm going to walk you through kind of what this signature version 4 algorithm looks like. There's three basic steps. We have to canonicalize a request. We then use that to construct a string that we're going to sign, and then we sign that string and stick that in the HTTP request. I'm going to go through this part a little bit quickly because if you really, really want to see it, you can go check it out on the public documentation. But just to give you an idea of what we're talking about, I'm going to go through this. So to start with, let's talk about how we canonicalize this thing. The top there, I've got kind of an example HTTP request to a example service. At the bottom is the format of kind of what goes into this canonicalized version of the request. Like I said, we have the request method. We have a canonicalization. The docs call it a canonical URI. What it really is a canonical version of the path component of the URL that you're hitting. And then we have a canonicalized query string and canonicalized headers and list of the headers that you are actually signing. And then we also include a hash of the request payload in that. So if we just kind of walk through this, make it clear, we start with the method, then we canonicalize the path by, we provide some pretty specific instructions on how you canonicalize that. We do reference some RFCs for that. Likewise for query string, we reference some RFCs. We also have specifics like you're gonna sort them by parameter name, then by value, etc. Headers, it's a very similar sort of thing. And then I'll tell you that's a hash of a payload, and you'll believe me. So that's canonicalization of the request. Next step is we take that and put it into a string to actually sign. And I think I actually skipped a step in my example there, but that's okay. Oh no, I didn't. Okay. So the actual string to sign has a few different components. First, we say we specify the exact algorithm we're using. In this case, it's this tag AWS4 HMAX SHA-256. All SIG v4 uses that, but it could change. We put in a timestamp for when we're making the request. We put in this thing we call a credential scope, which relates to how we derive the key that we're going to use to sign this. When we derive that key, we bind it to the day, the region you're AWS region you're communicating with, and the AWS service you're communicating with. And then there's finally the hash of the canonical request we just created. So you create that, and you sign it with a derived key. As I said, the derived key, we generate it using date, region, and service. It's basically a series of chained HMACs, starting with a secret key that both you and AWS know. You, like I said, do a bunch of chained HMACs, you generate this key, and then you sign your string to sign, and you have a signature. And then you stuff that generally into a header in your HTTP request, and you're good to go. And that's the end of what my actual slides contain. Whoops. Now let's talk about why we do some of this stuff and some of the lessons we learned. Where do I want to start with this? So
you have 3 minutes for that.
3 minutes, cool. All right, let's go quickly then. To start with, some obvious stuff. Crypto agility, it's good, it's important. That's one of the reasons we're on V4 and not V1, because we had to add that. So that HMAX SHA-256 bit there, that's important. Another thing we ran into over the years, protocol agility. We started out with a protocol that was very query string oriented, and so we were just kind of assigning query string parameters. Over time, that changed. We needed to put stuff in the body. We needed to put stuff in headers, et cetera, et cetera. We needed to extend the format to enable us to sign more of the HTTP request as a whole, because different protocols are running on top of HTTP are going to put different value on different parts of the request. Canonicalization, that was a big thing we taught. I mentioned that word a whole lot of times there. If you look at our documentation, it is very specific about how we canonicalize these things, because you have to be. Even something like URL encoding, you can't just say, go follow this RFC, because guess what? The RFC changes, or the list of reserved characters change, and then you have to deal with the fact that older libraries aren't doing it that way and newer libraries are. You can't just say URL encode and assume that the API is going to do it right, because if you look at languages, take JavaScript for example, there's like 3 different encoding related methods you could call, and they all encode things slightly differently. So we have to be very specific about that sort of thing. It gets, all right, yeah. Going back to signing different parts of the request. There's a reason that we specify what headers we're signing. And there's a reason we specify explicit ordering for query string parameters. It's because, again, you have to. Here, it's not so much an issue of how are things getting canonicalized, but an issue of middlemen between the person who is actually, the code that's actually trying to make the request and your server that's going to receive it. The obvious middlemen are things like proxies and load balancers and whatnot. Even if you throw those out, you've still got middlemen because you've got browsers, you've got SDKs, you've got language libraries that are going to get in your way. In case you don't believe me, just think about every API that lets you specify query string parameters as a map. Maps are unordered. How are those going into the URL? You don't know. So you have to have you have to specify how you're ordering those and how you're assigning those. More fun with headers. Going back to protocol agility, I talked about protocol agility for what's running on top of HTTP, but what about protocol agility for HTTP itself? When we went from 1.1 to 2.0, the host header changed from host to :authority. And so we had a bunch of services that were expecting the host header to be signed and required you to sign the host header. But now there's no more host header. So what's the client signing? Because they don't necessarily know if this request is going over HTTP 1.1 or HTTP 2.0. It might change over, as it's sent over the wire. So they have to deal with that as well. We thankfully, because of the flexibility in our protocol that you specify what headers you're signing, we were actually able to deal with that just with some code changes and documentation changes. We didn't actually have to rev the format. So that was kind of a positive there. The last thing I'll say real quick, if I've got one, yeah, cool. Performance, I mentioned a little bit earlier with asymmetric crypto. There's two different places where we kind of ran into some interesting performance challenges. One is symmetric versus asymmetric. Asymmetric would be awesome. It has great security properties, but there are honestly scenarios where it is just still too slow, and likely always will be, because as things improve to make asymmetric crypto faster, they're also going to be improving to make other parts of the system faster. And so you're still going to be looking at increases in latency that potentially double the cost of the API call. So that's something we have to think about. Lastly is, I mentioned signing the body of the request, the fact that we sign a hash of it, not the full thing. That's again why we're on version 4, not version 1 or 2 or 3. That was something we realized, hey, this is not a great idea. So another reason for flexibility in what parts of the request you're signing and how you're signing those. And that was my whirlwind tour through AWS SIG v4. If you Google AWS signature version 4, you will find our public documentation on it. If you want to dive into that and see a little bit more, there's also source code for all of our client SDKs pretty much on GitHub. You could look at how we actually do it there.
Annabelle, are you planning to bring this work as a specification to the IETF as sort of standardization, or?
That's an interesting thing to explore.
We can explore it later.
Yeah. I think that our presumption is that there wouldn't be interest, but yeah.
Not necessarily. Okay. Okay, thank you. So just going through this quickly. So we've talked about nested JOT last time. What was missing is use cases. So the issue with the JSON today, it defines the concept of a nested JOT, but it has a limitation of that. The enclosing JOT doesn't have its own claims. So the goal is to extend that concept and allow the enclosing JOT to have its own claims. There are 2 use cases that I'm aware of. One is a native app that interact with 2 different authorization servers. One is that the native app is aware of the first authorization server, but not the second one. And because we don't have time, and I'm not going to go through the flow itself, The second use case is a stir use case, actually, and it's too late actually to affect this this document because it's I think already with the ISG that allows that or needs that same concept of nested jobs, one inside the other, and with two different claims. And we've talked about, I'll talk about the example. So we've talked about defining a content type and a new claim to kind of define how would you nest those together, right? So I don't want to say too much because we don't have time right now. Go ahead.
I just quickly wanted to say that passport document is just submitted from the work group asking for publication.
Right.
So it's not that
Okay.
doable.
Okay, maybe it's doable. So we'll see. So who read the document? Any show of hands? 1, 2, 3. Okay, 4. I don't know if I'll leave it to you. It's
that's not enough people, I would say, have read it to make a call for adoption. Yeah, I think we'll read it. Okay.
Okay.
Yeah. So if
Can we get more volunteers
to read it. Okay.
okay. Good.
So
I don't have.
Phil.
Yeah. Perfect.
Phil, Nat,
Okay.
and
Okay. Perfect. Okay. And I will add the second use case, the stir use case. It's not in the document, but I'll add it. Thank you all, and we'll see you next time, I guess. Thank you.
Can I have a last word?
Of
course.
So administratively coming in, again, no value judgment on the work. What really always excites me when I come to OAuth is the tight link of people have code. I'm doing this thing, like I need this addition, and kind of the fast interplay is phenomenal. But from the governance artifacts we have, there is not a lot of insight into what's actually happening and what's on deck and what's the next step. The latest milestones are in July 2017.
Yeah.
It's tough to tell from the charter what working group documents
Yeah.
be on. So in the coming months, we're going to polish that on the mailing list. Just wanted
Yeah.
to put that out there. And that's just to make sure, again, my primary driver here is that we know where we're going. And one of my key things is there are folks that don't participate here and they don't understand that this being out of date doesn't mean we're not doing work. So our ability to talk about future milestones is signaling to the community that we have a lot of work to do, kind of keep watching this space.
That's a good point. Thanks, Roman. We have planned to do this already since 2017. So
It'll be the third AD audit.
perfect. Now I let as reviewers, I'll add myself to. I reviewed it, but I will post questions. My review to the list. Okay. And then we should after the review saying we should do a call for adoption on the list. I think that would be easy.
Okay. It's a simple job.
It's a simple thing, but a very useful thing.
Yeah, exactly. Yeah, for sure. Thank you.